Hello and welcome to Trigonometry, the study of right triangles. I'm really sorry that I'm not here today. Hopefully I'll be back later on in the week, although your next class will just be map testing. So those of you that are juniors, you will need to map test. So what I did is I handed out a pre-review worksheet, and this is all stuff from last year in Algebra 2, but I know that it's a lot. So I was hoping that everybody would kind of give these questions a shot, either by themselves or with a partner, just to see kind of what you remember from last year. And again, I know that this is a lot. This is basically the entire trigonometry unit from last year, all at one time in one class. So please do not beat yourselves up if you're struggling a little bit, because some of these questions are very, very challenging. But if we can get through this pre-review and understand it, I promise you the very first unit of trigonometry, this upper level class, will not seem very overwhelming. In fact, a lot of the stuff that we did last year in Algebra 2, you will see again in this trigonometry unit. So as we go through this, I encourage you to pause the video, try things on your own, double check to see if you got them correct. I'll try to go through these pretty quickly so that this lecture isn't too long, and we can definitely go over any questions that you have when I get back. There is no homework. The real homework is just making sure you can get through this review worksheet and understand as much of it as possible. So the very first question says to evaluate the other 5. Yes, there are 6 trig functions, if we remember them all. I've listed out SOHCAHTOA over here on the right. The one that partners with sine is cosecant, and that's going to be the inverse, so it's going to be hypotenuse over opposite. Cosine, that partners with secant, and that's going to be hypotenuse over adjacent. And then the one that partners with tangent is cotangent, and that's going to be adjacent over opposite. So the first thing that we have to realize is we don't have a ton of information. I encourage you to draw a triangle. Yep, trigonometry, the study of right triangles. So I have a right triangle here, and I'm just going to mark one of the angles that's not the right angle as theta, and I know that tangent is opposite over adjacent. So if this is my theta over here, I know that my opposite side is over there, adjacent is right here, and there's my hypotenuse. And because I know the tangent is 5 over 4, I have 5 over 4, opposite over adjacent. Now what I have here is a missing hypotenuse. I don't know what that is. I was hoping it was a 3, 4, 5 right triangle, and I would have made this nice and easy for us, but it's not. So in order to find the hypotenuse, I have to do the Pythagorean theorem. So I have to do 5 squared plus 4 squared. I get 41, and that's equal to my c squared value. So therefore my hypotenuse, or my c value, is the square root of 41. And let me just double check. There's no perfect square that goes into 41. No, there is not. So now that I have all of my sides labeled and I know my main angle there is theta, I can go ahead and fill out all of the other information. So since the tangent of theta was 5/4, let's just write down the cotangent of theta, which is just going to be the reciprocal, 4/5. Next, we'll move on and we'll do the sine of theta. So the sine of theta is opposite over hypotenuse, 5 over the square root of 41. And yes, I cannot have a radical in the denominator, just like before, right? I need to multiply by the square root of 41 over the square root of 41. So I get 5 square root of 41 over 41. Cosecant, which is just the reciprocal, and let's look at the very beginning before we kind of fix the radical part. I just take the reciprocal there, so it's a square root of 41 over 5. Last one here is cosine, so that's adjacent over hypotenuse, and I need to fix that radical, so I get 4 square root of 41 over 41, and that partners with secant, where I just take the reciprocal there, the square root of 41 over 4. So now I filled out all of the other trigonometric functions for this particular right triangle. Our next question is special right triangles. I encourage you, especially if you're juniors and you haven't taken your ACT yet, memorize the special right triangles. They can really help you. They can shorten the timeline. Remember, when we're taking an ACT, we're trying to get through those questions as fast as we possibly can. Here is a 30, 60, 90 triangle. I know I only have one of the angles labeled other than the right triangle, but here's a 30, 60, 90 triangle. And here is how the sides are in proportion to one another. Across from your 30 is your x, across from your 60 is your x times the square root of 3, and across from your 90 is your 2x. So over here, because across from my hypotenuse is 20, I know that across from the 30 degrees is just going to be half of that, so it's 10. And then across from my 60 is going to be 10 square root of 3. See how quickly we were able to do that just by understanding the proportional relationship of special right triangles. The next example is also a special right triangle. It's a 45, 45, 90 triangle, and they're set up that the sides are both going to be equal to each other because, right, we have an isosceles right triangle. So we've got x, x, and then my hypotenuse is x times the square root of 2. So over here, since I'm trying to find the sides, I know that my 10 value is equal to x times the square root of 2. And I would encourage you to just kind of think to yourself, what would I have to multiply by the square root of 2 and then wind up with 10? So try to think, okay, well, I know it's not 5. 5 times the square root of 2 doesn't equal 10. But how about 5 times the square root of 2 times the square root of 2? That equals 10. So each of my sides is equal to 5 square root of 2. If that didn't make sense, just kind of thinking through it, you also can solve this algebraically. Since I know my hypotenuse is equal to x times the square root of 2, all I have to do is I divide by the square root of 2, right? This is just a simple one-step problem. What makes it more challenging is I wind up with a radical in my denominator, so I have to get rid of that radical. So I get 10 square root of 2 over 2, which then simplifies down to 5 square root of 2. But like I said, if you can kind of memorize those proportional relationships, I really do think it will help shorten those problems down. Right, looking at number 4. So we've got some word problems. I try to write these word problems so that they're straightforward, but I know it can be very easy to draw the picture incorrectly. So let's draw these pictures correctly and make sure we kind of are getting the same answers. So a man over here, he's standing 90 feet from a library. So we'll say here's our library. The angle of elevation to the top of the library is going to be 33 degrees. Find the height. So what we're trying to do is find, how high up is that library? What is the height of the building of the library? So here I see, okay, I've got my angle here. I want to know my opposite value, and I have the adjacent value. So I've got to think, okay, out of my SOHCAHTOA, I really just want to use those main trig identities here. Which one uses opposite and adjacent? Well, it's tangent. So I know the tangent of 33 degrees is equal to the opposite value, that's what I'm trying to find, over 90 feet. So in order to solve this, I'm going to multiply both sides of my equation by 90, and I'm going to pick up my calculator. A lot of trigonometry you'll see this year, we're going to be using the calculator quite a lot. We have to really know how to use it. Make sure you're in degree mode on your calculator. You should get about 58.45 feet. That's how high the library is. All right, let's look at our next question. A 20-foot ladder. Right, so here's our ladder. And it's leaning against a wall with the top of the ladder at a height of 15 feet. What is the angle of elevation of the ladder? So we're trying to figure out that theta value. We're trying to figure out that angle there. So when I look at this, I say, okay, I have opposite and I have hypotenuse. So which trigonometric identity uses opposite and hypotenuse? Well, it's the sine. The sine of theta is equal to 15 over 20. So in order to solve this one, I need to use what's called the inverse of sine, or arc sine. Those signs over here cancel out. I get the theta is equal to arc sine, or inverse sine, of 15 over 20. So when you do this on your calculator, make sure you're still in degree mode, and you're going to hit second sine on your calculator, and it should spit out an angle value of 48.59 degrees. All right, let's go ahead and move on to our next word problem. The height of the Eiffel Tower is 1,050 feet. There we go. It's our Eiffel Tower. From the top, the angle of depression, so we've got a soccer ball over here. Now it says the angle of depression, right? These ACT questions, trig questions, love to use this. So the angle of depression is always from a horizon. So if I'm up here, it's actually going to be from the horizon down. So that would mean that this is 20 degrees, which means this is also 20 degrees. So make sure you draw that picture correctly. Find the distance between our soccer ball over here and the base of the Eiffel Tower. So that's what I'm trying to figure out. So I've got my angle, I've got opposite, and I'm trying to find adjacent. So that tells me I need to use the tangent. So the tangent of 20 degrees is 1,050 divided by x. So in order to solve these, if you kind of remember from last year, or you can prove it out to yourself, we're going to flip-flop those values. So I'm going to pick up my calculator and do 1,050 divided by the tangent of 20 degrees. Again, I want to make sure that we're in degree mode, and you should get out 2,884.85 feet. All right, moving on to our next question. Sketch the angle in standard position. Okay, let's just remind ourselves about kind of our angles here. So we've got 0, and then when I go around our unit circle or around kind of the coordinate plane, I'm going to go in counterclockwise order. So up here is 190, down here is 180, then we got 270, then we're back up to 360, right? And I'm going to keep circling around counterclockwise. Now, if my angle measure is negative, that means I'm going to be going clockwise around. So for negative 710, so I'll start here and I'm going to be going clockwise because it's negative. So I go around once, that's 360, and then I need to go another 350. So not a full beat around, almost all the way around, but I have a little bit of 10 degrees left over there. So that is where my angle is. Now, when I ask you to do this, really what I'm looking for is, have you drawn the angle in the correct quadrant, right? So don't worry about if your line's up here or over here. I'm trying to check, did you put this angle in quadrant 1? Because really we're sketching it. I know it's not going to be perfect. All right, 212 degrees, that's going to be a regular counterclockwise. So I'm going to go 180, but then I'm going to have to go a little bit more down. In fact, how many more down? 32 degrees more. So our angle winds up here in quadrant 3. Our last one is negative 516. So I'm going to have to go all the way around 360. And remember, I'm going to be going clockwise in this case. And then I'm going to have about 156 more. So I'm going to have to keep going. And again, I wind up here in quadrant 3, so notice my angles look exactly the same, but in this case, I still have 24 degrees to go if I wanted to get back to the x-axis. So both of these do wind up in quadrant 3. All right, so the next vocab word, or a vocab word that we should remember, are coterminal angles. So those are angles that are going to wind up in exactly the same spot on our axis. So how many degrees around is our unit circle, is the coordinate plane? It's 360 degrees. So when I'm trying to find positive and negative angles that are coterminal, all I need to do is add or subtract 360 degrees from our base angle there. And I will wind up with the exact same angle. I will just have gone around the circle one more time. So I'm going to take negative 125 degrees and add 360. I'll get 235 degrees. I'll also subtract 360 and get negative 485 degrees. Over here, we're going to do the same thing. So I get 660 degrees and then negative 60 degrees. Now, I need to do the same thing, but doing it in radians. So one of the big units we need to remember is that pi radians is equal to 180 degrees. 2 pi radians, therefore, is equal to 360 degrees. So I need to add or subtract 2 pi radians from here. So this means you're going to have to do a little bit of fraction math, because remember, when I add or subtract fractions, I need to have the exact same denominator. So I'm going to rewrite 2 pi as 12 pi over 6 So I wind up with 13 pi over 6 and negative 11 pi over 6. Go ahead and try 3 pi over 4 on your own.